Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section, I am going to discuss about the valency factor students. I am giving the best excellent trick to find the valency factor, how to find it. Okay, now this topic, it is based on this, we are going to find the equivalent questions students. Okay, Namma. So first of all, what is the normality? Okay, normality definition I will discuss students. What is the normality students? Normality is equal to number of gram equivalents of the solute present in the 1 liter of the solution. Correct? Number of gram equivalents, that is nothing but E by present in the 1 liter of the solution, that is volume. Are you following students? This is the number of gram equivalents. Number of gram equivalents present in the 1 liter of the solution, that is nothing but volume. Okay, Namma. So E by V, normality formula students, N is equal to E by V. So from this formula we can write N is equal to E by V now. So we can write it as E is equal to what we can write students? E is equal to N into V. Okay, so this is the first formula students. Okay, Namma. N is equal to E by V. From this formula we can write E is equal to N into V students. Okay, Namma. Next one, see students, here what is E students? What is E? E is nothing but weight by gram equivalent weight. Correct? E is nothing but number of gram equivalents is nothing but weight by gram equivalent weight. But we know that another formula, gram equivalent weight is equal to gram molecular weight by valence factor, or N, gram molecular weight by N. Okay, now, or valency factor students, gram molecular weight by valency factor. Clear this one? So this is gram equivalent weight students. So this formula here I am going to substitute. Then what I will get, Nana? E is equal to what I will get, weight by gram equivalent weight means gram molecular weight by valence factor. So gram molecular weight, this valence factor will go to the up. So here E is equal to weight by gram molecular weight into valency factor. This weight by gram molecular weight is nothing but number of moles. Correct? Weight by gram molecular weight is nothing but number of moles. Are you following students? So these are the formulas. So this formula here I am writing. So E is equal to what we can write, N into volume factor. Correct? In this place I am taking N value. So N into volume factor students. Clear this one? So E is equal to N into volume factor. Okay, I am taking like this. So if suppose the two solutions gram equivalents are equal, then E1 is equal to E2. Okay, now E1 is equal to E2. Then how to write students here from this equation 1? This is the equation 2. This is also E is equal to what students? E is equal to NV, gram equivalents, and here also equivalence is equal to N into volume. This is the N into valency factor students. And one more formula also we know, that normality is equal to what we know, relation between normality and molarity. What is the relation students? Normality and molarity relation. So normality is equal to the volume factor into molarity. Are you following? Normality is equal to what we can write students? Normality is equal to one more formula, volume factor into molarity. Are you following? So this we know, that relation between normality and molarity. So this is the equation 3 students. 1 2 3 equations. If E1 is equal to E2, so what we can write students from here, from this formula, N1 V1 is equal to N2 V2. Correct? E1 equal to E2 means N1 V1 is equal to N2 V2. And next thing is V1 F1, here another formula, E is equal to N into volume factor na, N into volume factor. So from this, if E1 is equal to E2, then what we can write students? Formula N1 into V1 F1. Are you following? So volume factor into N kada. So volume factor, sorry, not volume factor, nana, valency factor. So valency factor 1 into N1 is equal to valency factor 2 into N2. Are you following students? Into N2. Clear, nana? So and we know that normality normality is equal to volume factor in valency factor into molarity. So here normality place, here I am taking this formula students in this one. So n1 is equal to what, Nana? We volume valency factor into molarity. So here you substitute. So valency factor 1 into molarity m1 v1 is equal to n2 means again valency factor 2 into molarity m2 into v2. Are you following, students? So these three formulas are very important, students, understanding. So these three formulas we using in the problems, Nana. n1 v1 equal to n2 v2. So from this one, if e1 is equal to e2, so what I wrote, n1 v1 is equal to n2 v2. If I take this formula, second formula, e1 is equal to e2, then v1 valency factor 1 into n1 is equal to valency factor 2 into n2, second relation. And third relation, we know that relation between normality and molarity. So from this formula, normality is equal to valency factor 1 into m1 into v1. Here I substituted, Nana. Here you will get the three different problems, different formulas, students, understanding. So these are the formula, students, important formulas. Okay, na? Important formula, students, these are. Okay, these three formulas, please remember. Then based on these formulas, we can do the problems, Nana. Okay, next, how to find the valency factor, Nana. Okay, na? So first of all, what is the valency factor? Valency factor, Nana. See here, what is valency factor? So valency factor is equal to the change in oxidation number. Change in oxidation number, understanding, change in oxidation number into number of atoms, students. Are you following? So valency factor, how to find it, students? Change in the oxidation number into number of atoms, Nana. Now how to find for the compounds valency factor? Now I'm going to discuss, students. See here, I'm taking one example, Nana. MnO4. First example 1, students. MnO4 minus, it is converted into Mn plus 2 in acidic medium. Okay, now what is the valency factor of MnO4 minus? Okay, now what is the valency factor? How to find it, students? What is the valency factor, Nana? Here, valency factor of here manganese. Here manganese, how much an oxidation number? +7. Okay, now +7. Here, understanding, students, oxygen always -2 showing. So manganese oxidation number is +7. Okay, if you want, you can calculate, students. Manganese I don't know, I have to find. 4 oxygens are there. 4 into -2 is equal to how much charge given? -1. So x minus 8 is equal to -1 plus 8. So x is equal to +7, students. So manganese oxidation number is +7, here +2. So that's a how much difference, students? Change in the oxidation number, +7 to +2. Manganese oxidation number changing from +7 to +2. How much difference is there, students? 5. Correct, Nama? So here valency factor is equal to 5. 5 difference is there. +7 to +2. 5 difference into how many atoms, students? Number of atoms. Here 1 manganese, here also 1 manganese atom. So one atom. Here also 1 atom, here also 1 atom. So that's you have to take number of atoms 1. So 5 into 1, 5. Like this you have to find it, students. Okay, Nama? In the acidic medium, this one. Now coming to the second example, see, students, what is the second example? I am taking the Cr2O7 minus 2. Cr2O7 minus 2 in acidic medium, it is converted into Cr plus 3. Okay, na? Cr plus 3. Here, how to find the valency factor, students? Okay, now how to find the valency factor of dichromate of the potassium of the dichromate? Okay, so how to find it, students? Here see Cr2 chromium oxidation number, you have to find it first. Okay, how to find it, Nana? 2 chromiums are there, 2x plus 7 into oxygen minus 2, or here charge already -2 given. 2x minus 14 is equal to -2, 2x is equal to +12, x is equal to +6, students. So chromium oxidation number +6, here +6, plus 3. 6 to 2 plus 3. That means how much oxidation number changed, students? 6 to plus 6 to plus 3. Total oxidation number changed. So valency factor is equal to change in oxidation number is 3. 6 to 3. That means 3 is the difference. And number of atoms. How many atoms are there here? 2 atoms are there. But here how many atoms are there, students? Only 1 atom is there. So you have to multiply with the number of atoms. How many more number of atoms are there? That number you have to take, students. Are you clear this one? Change in the oxidation number. Here 2 atoms are there. So that's it. To balance this equation, I am taking the 2 moles. Clear this one. So 3 into 2, how much, Nana? 6. Here equal number of atoms kada. That's why here taking 1 only. But here 2 atoms are there. Here only 1 atom is there. To balance this one, you have to multiply with the 2. So that's why you will get the valency factor 6, Nana. Clear this one. Now one more example I will discuss. See, what is the third example? Example 3. Okay, what is example 3, students? Oxalate ion C2O4 minus 2. It is converted into CO2, students. It is converted into CO2. Now I want to find the valency factor of oxalate ion. Oxalate. Okay, na? So what is the valency factor, students? Now see, carbon I want to calculate oxidation number. Oxygen I know that minus 2. So how to find it? 2 carbons are there, 2x plus 4 oxygens, 4 into minus 2. How much charge is there? Minus 2. 2x minus 8 is equal to minus 2. 2x is equal to plus 6. X is equal to plus 3, students. So carbon oxidation number is plus 3. In the case of carbon dioxide, carbon oxidation number is how much, Nana? I am not taking here any balanced equation, students. Okay, na madam, here 2 carbons are there, 4 oxygens here not balanced. No. I'm not taking the balanced equations. Clear this one. So here x is equal to plus 3. Now coming to the carbon dioxide, oxygen minus 2, students. What about carbon? X plus 2 into minus 2 is equal to 0. X is equal to plus 4. So carbon oxidation number is 4. Carbon oxidation number plus 3 to plus 4 changed. So that means how much changed, students? How to find the valency factor? So valency factor is equal to change in the oxidation number 1. And here how many atoms are there? Carbon atoms. Here 2 are there. Here 1 is there. To balance that, you have to multiply with 2. That is the formula, number of atoms. So 1 into 2 is equal to 2. So this is the valency factor of oxalate ion. Are you following? Next one, one more example, students. See here, example 4. So what is example 4, Nana? Copper sulfide I am taking. Cu2S, it is converted into Cu plus 2 plus SO2. Okay, Cu plus 2 plus SO2, Nana. Cu plus 2 plus SO2. Now tell me, students, what is the valency factor of copper sulfide? Cu2S. So what is the valency factor? So first of all, you have to find the oxidation number, students. Okay, na? So sulfur here, oxidation number is minus 2, students. Oxidation number of sulfur is minus 2. And here copper we don't know. So that's why I'm going to find it. So here copper sulfide 2x plus sulfur minus 2 equal to 0. 2x minus 2, 0. X is equal to plus 1. So copper oxidation number plus 1. Here plus 2 given. Here oxygen minus 2. Sulfur how much? X minus 4 equal to 0. X is equal to plus 4. So sulfur oxidation number is plus 4, students. Now copper oxidation number changes from plus 1 to plus 2. Correct? Plus 1 to plus 2. How much oxidation number changed, students? 1. So that's why valency factor here in the case of copper, first you have to find it, and sulfur oxidation number also changed. So you have to find the valency factor for sulfur also. Okay, now. So here 2 valency factors you have to find it, because copper changed, sulfur also changed. Are you following? So that's a 2 valency factors you will get. After that, you have to find the valency factor of copper sulfide. That means you have to take the sum of both valency factors. Understanding? For example, copper oxidation number is changing from copper plus 1 to plus 2 kada. Copper plus 1 to plus 2. Okay, So Cu plus 1 to copper plus 2 changed. So that means how much oxidation number changed, students? This valency factor how much? Cu2s kada. Now tell me valency factor is equal to how much, nana? One oxidation number changed. How many atoms? 2 atoms. So valency factor of copper is 2, nana. Okay, now I'm going to calculate sulfur also. Sulfur here -2, here +4. So here in the case of Cu2S2SO2, sulfur oxidation number -2, here +4. That means oxidation number changes from -2 to +4 to nana. No, not 2. Here -2, here +4 nama. So that means here this is the oxidation reaction. How much difference will be there? +6. Correct. So because here if you add to -2, if you add +6, then you will get the +4. Are you following? So here how much oxidation number changed, students? 6. Clear, nana? So you have to calculate like this, nana. Understanding? So like this you have to find it. How much oxidation number is changed, students? Okay, how much? +6. Clear. Change in the oxidation number is +6. So valency factor is equal to 6 into how many atoms? How many atoms sulfurs, nana? Only 1 atom. So that's the valency factor is equal to 6, students. Clear this one. So -2 to 4 means how much difference is there? How much, nana, difference? When we'll get the +4? If you add +6, then you will get the +4. Clear this one. Understanding, students? So like this you have to find it, nana. So here +4. So 6 into 1 is equal to 6. Understanding this one? See, students, you have to calculate. Here you will get the little bit confusion. Why, madam, here 6 came? Now see, students, just you remember when you are going to calculate the valency factor, change in the oxidation number, big number minus small number you do, nana. Okay, now change in the oxidation number when you are calculating change in the oxidation number, you have to do big number minus small number you do, nana. Then you can easily find out. See here, which is the -2 + 4, which is big number? 4 kada. Big number minus small number. So big number is +4 minus small number. How much small number? -2. That means 4 minus into minus +2. That is, sorry, +2. 4 + 2, 6. So that is the change in the oxidation number, students. See here in these two, in these examples also you can calculate like that also. Here +1 copper, here +2. Big number minus small number. 2 minus 1. So 2 minus 1, 1 is the change in the oxidation number, students. Now see here how much change in the oxidation number? Here +3, here +4. 4 minus 3, 1 is the oxidation, 1 is the change in the oxidation number. So that's why 1. Are you clear? In these examples also you can calculate like that only. Are you understanding? So it is the big number is 6. Here small number is +3. So big number minus small number, 6 minus 3. How much you will get, students? 3 is the change in the oxidation number. Here also big number minus small number does. That is 7 minus 2. You will get the 7 minus 2. You will get the change in the oxidation number is 5. Clear? So change in the oxidation number is 5, students. So like this you can calculate. So here you will get the valency factor is equal to 6. Understood, nana? This is the example 4. Now see, students, in this case copper we calculated how much copper valency factor. Copper valency factor is 2, nana. Okay, na? And valency factor of sulfur we calculated here -2 to 4. So this is 6. Here copper and sulfur both we calculated. This is the valency factor of sulfur, copper, students. This is the valency factor of sulfur. So this one, this both you have to add, nana. Then you will get the copper sulfide valency factor. So valency factor of Cu2S is equal to 2 plus 6. How much, nana? 8. So this is the valency factor of copper sulfide. Clear this one? And one more last example, see, students. Example 4. Iron oxalate, FeC2O4, it is converted into Fe plus 3 plus CO2. Okay, now plus CO2, students. So like this it is dissociates in acidic medium. So iron oxalate. So what is the oxidation numbers? You have to find it, students. Here oxygen is always -2, here also -2. Iron, here how much, students? Iron Fe +2, here Fe +3. Carbon how much? Here I have to find it, this carbon and this carbon. Just you calculate this one. 2 plus 2 carbons 2x, 4 oxygens, 4 into -2, total charge is 0. So how much you will get, students? 2 plus 2x minus 8 is equal to 0. 2x minus 6 is equal to 0. X is equal to +3, students. So that means how much oxidation number, students? Here carbon +3 oxidation number. Now coming to the CO2, carbon oxidation number, X plus 2 into -2 is equal to -2. Sorry, if the CO2 oxidation number is 0, then X minus 4 is equal to 0. X is equal to +4. That means carbon oxidation number is +4. Iron +2 to +3 changed, correct? Iron +2 to +3. So 3 minus 2 big number. 1 is the change in the oxidation number. How many atoms are there? Iron here 1. So that means 1. It is the valency factor of iron. Clear this one. So what is the valency factor of iron, students? 2. And next coming to the carbon oxidation number is changed, here 3, here 4. So that's why here 3 to 4 means 4 minus 3 you will get 1, change in the oxidation number 1. But here how many atoms are there? Here 2, here 1. So that's why 1 into 2, 2 you will get, students. Are you clear this one? So 1 into 2, 2. So that's why carbon valency factor of carbon is equal to 1 into 4 minus 3, how much, Nana? 4 minus 3, 1 into how many atoms are there? 2 atoms. So that's why it's valence, uh, change in the oxidation number 1 and the number of atoms are 1. So that's, sorry, 2. Then you will get 2. So total valency factor of iron oxalate FeC2O4 is equal to 2 plus 2. How much, students? 4. Clear, Nana? So valency factor is equal to how much, Nana? It is iron oxalate kada. So valency factor is equal to 4. 4 you got, Nana. Once again we'll check, Nana. Iron, no, iron 3 minus 2, 1. And one more, sorry, 1 ones are 1 kada. Sorry, students. So iron valency factor of iron is equal to 1 because 1 atom only there, and change in the oxidation number 3 minus 2, 1. So 1 into 1, 1. It is valency factor 2. So 2 plus 1 is equal to how much, students? You will get 3 value. Understood, Nana? So 3 we got. Valency factor is equal to 3 we got. Now see, students, I am discussing the problem based on the valency factor. Now how to find it? See, students. See, students, what given? What volume of 0.3 molar potassium dichromate is required to oxidize 100 ml of 0.4 molar sodium oxalate in acidic medium is asking question, students. Are you clear this one? So these are the valency factors. Before already we calculated now, so that all I wrote, students, here. So here which one asked, Nana? Molarity asked and volume given. Molarity, volume given. So molarity volume relation you have to take. So what is the molarity volume relation, students? Relation between molarity and volume. So here I discussed you some formulas, correct? Here what formula I discussed, students? Molarity and volume. So molarity and volume valency factor we have to find it, students. So molarity and volume factor, molarity and volume valency factor. So this formula we should use. Clear this one? So this formula we should use, students. So Vf1 m1 v1. So what is the formula, students? Valency factor solution, Nana. Valency factor Vf1 into m1 into v1 is equal to valency factor 2 into m2 into v2, correct? So valency factor 1, how much, students? Potassium dichromate valency factor 1, how much given here? Valency factor potassium dichromate. So dichromate ion you have to take 6, Nana. Dichromate ion in the last class, in the last I discussed the valency factor, how to find it. Cu2s dichromate ion in acidic medium, yes or not? So here I discussed now everything. So dichromate ion valency factor is 6. So that one MnO4 minus valency factor is 5, correct? So this all I wrote here, students. Now see valency factor of potassium dichromate K2Cr2O7. So that is dichromate ion. You have to take 6 nano valency factor. So valency factor is equal to 6. So that's why you write here 6. What is M1 molarity of dichromate, students? 0.3 given. Volume we have to find it. V1 is equal to valency factor of sodium oxalate. That means oxalate ion you have to see. Where is oxalate ion? What is the valency factor? 2. 2 into molarity how much given? 0.4. Volume how much given? 100. So we have to find volume. So 2 into 0.4 into 100 by 6 into 0.3. Okay, Namma. So how much you will get, students? This value V1 is equal to 2 into 0.4 into 100. Clear, Nana? 100 divided by 6 into by 6. Here into 0.3 is there na? In calculator we have to do divided by 0.3 divided by 6, again divided by 0.3 you have to do, Nana. Again divided by 0.3. Are you following? So then you will get answer 44.44. Are you clear? So this is 44.44 ml, Nana. So this much 44.4 ml dichromate is required to oxidize 100 ml of sodium oxalate. Are you clear this one? So like this you have to find it, students. Now see one more problem, Nana. It is a different model problem. How many moles of KMnO4 will be required to react completely with 1 mole of copper sulfide in acidic medium? Here mole to mole relation is asking, students, only mole to mole. So how many moles required means here what is the formula, students? Mole to mole, only number of moles. So this formula we can use. So that means N1 valency factor into N1 is equal to valency factor 2 into N2. So this formula we should use, Nana. See here valency factor 1 into valency factor 2. See here valency factor solution. Valency factor 1 into number of moles N1 is equal to valency factor 2 into number of moles N2. So valency factor 1 KMnO4 valency factor how much, Nana? Here I told you now valency factor of manganate ion, permanganate ion. This is MnO4 minus, this one is 5 and one more is copper sulfide. So this one is how much, students? 8. So 2 8, correct? Oxalate ion. So KMnO4 kada 5 valency factor. What is the number of moles, students? KMnO4 number of moles only we have to find it. Valency factor of copper sulfide. What is the copper sulfide valency factor, students? 8. Valency factor is how much? 8 kada. So that's why you have to take 8 into number of moles of copper sulfide 1 given. So N1 is equal to 8 by 5. So 8 by 5 moles. Clear, students? So like this you have to find it, Nana. Valency factor problems, students. These are all valency factor problems. These are the models. Okay, I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, Nana. Okay, thank you very much, students.